Good morning to all of you. In this lecture, I will discuss about the concept of torque on a dipole, torque experienced by a dipole, and I will also solve few examples based on this topic. So, the torque on a dipole. So, consider a uniform electric field as indicated in this figure, and this is the we have this dipole, and this dipole makes an angle theta. This dipole, this is the dipole plus, we know dipole is an arrangement of two equal and opposite charges separated by a certain distance. So this is a dipole which is placed in a uniform electric field. Uniform electric field, and this dipole P makes an angle theta with the electric field, with this electric field. So torque on a dipole is the force experienced by this charge is, what is the force profile? This is simply the force experienced by this profile is F equal to Q. And what about this force experienced by, this is F equal to again QE. One is due to positive charge and another is due to negative charge. So the net force is 0 if the dipoles are collinear, if they are on same line. But in this case, the net force are not collinear. So they form clockwise torque. That is why we are studying the torque on a dipole. So torque on a dipole is represented by letter tau. So this tau is basically, and this is vector quantity T cross E. If the angle between them E and P is theta, then this is PE tau equal to PE sin theta, just like a cross product of two vectors. So PE sin theta. So it's all about the torque on a dipole. Now let us solve the examples to visualize the actual concept of torque, that and how to calculate the torque on a dipole. So let me give you the example. So in this example, we have a figure. The following figure shows an electric dipole in a uniform electric field, and electric dipole in a uniform electric field of magnitude 5 into 10 to the power 5 Newton per Coulomb, that is directed parallel to the plane of figure. Parallel to the plane of figure. The charges are, full stop. The charges are simply plus minus 1.6 into 10 to the power minus 19 Coulomb. Both lie in the plane, and are separated by 0.125 nanometers. So find the magnitude of dipole moment and torque. Find magnitude of dipole moment and torque. So this is the example that we have. So we have information about electric field. We know how. So first we have to calculate dipole moment. Let me write solution. And we know dipole moment P is Q into separation distance. So we have a separation R separate distance. We know we have idea about charge and separation distance. So our charge is Q is 1.6 into 10 to the power minus 19 coulomb, and separation distance which is 0.125 nanometer or 0.125 into 10 to the power minus 9 meter. This is in amperes. So what is our P? P is simply charge into separation distance. So we have a charge 1.6 into 10 to the power minus 19, and separation distance is 0.125 into 10 to the power minus 9. So this is, just multiply this number and we have into 10 to the power minus 28. Q into D means coulomb meter. Unit of this P is Q into D. Or we can write it as 2 into 10 to the power minus 29 coulomb meter. This much dipole. So in this way, in earlier example we have also, in earlier lecture we have also discussed how to calculate the dipole moment for a given charge and separation distance. So same thing is here. Now next part is torque on a dipole. So magnitude of the torque. So we have to calculate the magnitude of torque. Let me draw the figure, because in the starting we have the following figure. The figure corresponding to this problem is this one. So we have a uniform electric field and dipole are placed so if this is the electric field, so this angle is, this is what we have information about 145 degree and this one is 35. This is already given in figure, and this is plus Q charge and this is minus Q charge. So we have information and we have to find out the torque, and this is the direction of dipole and this is the direction of E, and this angle is 145. So let's say this is figure A and this is figure B. So we have to, this angle is angle made by the dipole through electric field. So this is our interest. This is our interest. So torque on a dipole is simply tau E P cross E. So P E sin theta. And what is theta? Theta is the angle. This is very important point. So you should keep in your mind that what is theta in P cross E. So this theta is angle made by this dipole. This is the direction of dipole. This is the direction of dipole. So this is P. So this theta is the angle made by dipole through the field. Through the field. So this angle not going to participate in our calculation. So this is the angle theta, which is, so in this case our theta is 45. And what is our P? Now putting the value of P E sin theta and evaluate it. So we have a P from part A. P is simply 10 to the power minus 29 coulomb meter, and E is already given. The electric field is 5 into 10 to the power Newton per Coulomb sin 145. This is not 45, this is 145. So now sin 90 plus theta, sin 90 plus theta is simply cos theta. So this is simply cos 60. So 90 plus 60. 90 plus 60 is 145. So this is simply cos 60. Now this, so this is tau. Now putting and calculating, after putting all the values and calculating, we have a profile 5 into 10 to the power minus 24. And what is the unit? Newton meter. So this is this much amount of torque experienced by this situation, and this is the way to find out the torque on a dipole, and the angle is made by this dipole through the field. So it's all about the torque on a dipole, which is P cross E. Its unit is Newton meter, and we have already discussed how to solve the examples or how to calculate the torque on a dipole for a given electric field profile and charge and separation distance. Thank you.